Oh, what a day! What a lovely day!
Good evening and welcome to Flat Earth United. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and keep hitting that bell notification icon so you can keep up to date with the Flat Earth debate. Now, joining me this evening is Rich, otherwise known as Thrive and Survive, and Anthony Riley. How are you both doing?
All good, good.
Yep, very good. Thank you.
Excellent. We are now live. So I know there's a bit of faff beforehand. I know Rich tried to go live and now I'm doing it in place. So this is kind of Rich's taking the lead here because it was him that sort of instigated the chat. So I know you've got a lot to talk about, Rich, because you've been very, very active. So maybe you want to kick off by telling us what you've been doing recently.
Well, my latest thing has been this refraction stuff and the Metabunk site and what is standard refraction and how is that computed. And at best, it's based on the something like you guys have been talking about a lot. It's based on the assumption of R for one, and it also ignores Snell's law, which has actually been physically documented to be true. The scientists have done actual. This is back in the 1800s when they came up with this. So this is, or even earlier. This is why it's true. They've taken different mediums and shown how refraction works, and shown how even any medium, water to water, air to air, whatever, there is no refraction, or extremely negligible if you have an extreme difference in temperature or something like that. So in my latest video, I went through Snell's law, and there's two main things to Snell's law. One is going from one medium to another is how you calculate how much refraction is. So on the Metabunk website, if you have standard refraction, which is based part of it on the radius of the Earth and part of it on God knows what. But there's mathematical formulas for the atmosphere, for different liquids, for a vacuum. And if you're looking at the atmosphere through the atmosphere, there's no change in medium. So there should not be any normal, what we would call refraction, where you have a rising of something on the horizon. Now, you can go online and see, there's plenty of drawings. I've even seen where you're looking at a tree half a mile away and it's raised up in the sky because of refraction. It's like, come on. So then we got into talking about what is mirage, what is a superior mirage. Now that is refracting taking place, but it's not the same as rising something on the horizon. That's a totally different thing. That's a change of medium. When you have what's called an inversion layer, which is where air normally gets cooler as you go up. As you go up, it warms instead. And then at the top of some layer there, it'll start cooling again. And that in between is a thermal layer. And that's what can cause refraction, where you see these things flip upside down, a superior mirage. Now, the globe Earth people want to say every time you see something beyond the curve of the Earth, it's a superior mirage, which is bunk. And that was actually beautifully shown, although I'm sure he didn't, I won't mention the name, but the one video I did yesterday showed where he was filming Chicago with a superior mirage. You could see all the buildings, and I don't know the mathematics because I don't know how far away it was taken, but on top of that was a superior mirage inverted, which I've never witnessed ever a superior mirage, and I was out to sea for 3.5 years. I've never witnessed a superior mirage where the top was not inverted upside down, and that's exactly what he showed. So the buildings on the bottom were real buildings. And I've also never seen a superior mirage where you couldn't see the original item being flipped up. So you know what I mean? You have to, your eye has to.
I've got one. I've got one to run by, and you can tell me what we're seeing, because we think it's looming, but we don't really know what it is, because what it is, you have the actual horizon, and then the topography of the land that should be on the horizon isn't actually on the horizon for some reason. It's on another horizon that's above it. And instead of it being inverted upside down and then back the right way up again, there's no inversion and there's nothing underneath. It's as if someone's got the copy tool and copied it above it, but not left the horizon where it was. It's bizarre.
Okay, yeah, I'll take a look at it. Now, what is their anyway? Let me finish with this, and then I want you to tell me what the definition of lumen is being used as and what people are saying about it, because I haven't kept up on that discussion. That's one thing. So I'm just describing the difference between a mirage and just straight out refraction. There's a difference. So one is violated because you're not going from one medium, let's say water to air, air to water, vacuum to air, air to vacuum. See, if we see the stars in the sky, technically we're going from atmosphere to vacuum. So there should be a slight amount of refraction to where the starlight is not exactly where it is. There should, and that kind of disproves what they try to show with Einstein's theory, where, oh, we saw a star eclipse behind, or on an eclipse behind the star, behind the sun, it bent. Well, maybe it's bent because you're looking from the horizon out, and you got a little bit of refraction. They never talk about refraction then when they're talking about those kind of things. But suddenly on the Earth, we have refraction when we're one medium to the same medium, which violates Snell's law, number one. The second leg of Snell's law is that you have what's called an angle of incidence, which is a variation off the normal angle. So if you are, you have a long, let's say, fence, and you're on one end looking, you bend down and you're looking parallel to the fence, you're just above it. Your angle of incidence then is zero, meaning you're looking 0 degrees, your eye up your eye right to the edge of the fence post and look down it. That is a 0 angle of incidence. Now, if you lay down on the ground or go kneel down halfway and look up at the fence on an angle, that's an angle of incidence. Now, what Snell's law says is that when you have different mediums like air to water, the amount of bend you will get depends on your angle of incidence. Now, if you have a 0 angle of incidence, for example, you're standing looking at the horizon at a distance, we all know that's at eye level, so there is no angle of incidence. So with 0 angle of incidence, when you plug the math in, there is no refraction, even if you were going from air to water, let's say. Now, I took the figures that were on the Metabunk site, which shows 0.04 degrees of refraction with the numbers I plugged in. I went back to Snell's law, plugged it in, and it would say we'd have to be looking from air into, what was it, ethanol. That's how thick it would have to be to get the amount of refraction he has in the Metabunk website. So there's angle of incidence is 0, and no matter what you put in, you can go from air to a thick jello goo, and you're not going to get any refraction at all if your angle of incidence is 0. And that's what I argue it is when you're looking at the horizon. So it's violated twice. And to me, violating an actual law of science, not a theory of science, and I know what the definition is, which says that it is based on established facts, but that's all BS. Scientific theory is not based on established facts. For example, the theory of relativity, the theory of relativity is a steady value of C, and that has been changing, and science is trying to explain that away or figure out how to explain that away and still keep Einstein's theory. Einstein's theory was solely put out there to debunk Michelson-Morley. Leaving that, but the theory of evolution, we see no species in between. We see no mutations that advance a species. And this is what that theory is based on. The Big Bang Theory. Nothing exploded and became, not only did it violate the second law of thermodynamics, which is entropy, everything goes from order down towards chaos, but that explosion caused chaos to go to order. So where are the established facts in both of those theories? So they will argue that just because it says in the definition of Wikipedia or wherever you go that a scientific theory is based on established facts, if you look at most scientific theories, they're based on assumption. But a law is different. A law is usually applied by actually doing real science, applying maths to it, and seeing what you come up with. And Snell's law absolutely destroys the standard refraction BS. So that's my spiel on that.
Yeah, I want to show you three things. I want to show you a couple of papers from MIT, and you used the word negligible before. That's right. Kind of like the buzzword when it comes to refraction for me, because I use that word all the time. And we haven't had refraction as a topic for a while in the debate channel because it seems to have died. Because every time we talk about it, I pop up with these papers and it very quickly goes away. Refraction is negligible. But I agree with you. When you get down to basically a 0 degree angle, Ranti's showing daily that observations of a foot above water are yielding the most incredible results over like 18 and 22 miles. we can see the baseline of the buildings on the beach, and it's from a foot above the sea. Now, sea as in tidal, as in salinated. It's not fresh water, it's actual tidal sea, and just 1 foot above the waves, Ranty can see the beach to beach, and the ballers ignore it. They just think that refraction, and it's like, no, it's ridiculous. So if I share my screen there, Nathan, and then pop this up, let me know when we're on, Nath.
Yeah, you're on. You were on anyway. But there we go.
Are we still on?
Yeah.
So I'm going to cite three pieces of paper, three papers that are quite interesting. This one's to do with computer generation, computer simulation, and what they're trying to do is recreate the atmosphere on a computer. I did get in touch with this guy called Diego Gutierrez, but once we told him what we were trying to discuss, he basically went silent on us, which I found was interesting, but nonetheless. In this paper, it talks about Fermat's principle on the trajectory of light, but then it talks about how you can apply Snell's law, and it's when you read through it, it's like the tip of the cap to the bit where it goes beyond science into pseudoscience, and I laugh at it when I read it. But basically, it's really bad. But nonetheless, this is the bit I always cite from it. It says, under standard circumstances, of which you would expect these to be the same circumstances that Metabunk bases their 7.6R on, it says that the effects are negligible. And I always go to the dictionary and like literally define the word negligible, because some people try and distort it into significant, but negligible means not worth calculating for. But they refuse to accept it because, well, it kind of goes totally against their argument. So that's one paper where it talks about the effects of refraction being negligible. Here's another paper I found recently. The refractive indices of water vapor, air, oxygen, nitrogen, hydrogen, deuterium, and helium, which is pretty much all of our atmospheric gases, right? And cutting a long story short in this, all I normally do on this is if I type in the word negligible, it talks about, it says, showing that the absorption line at 22,000 MCS has a negligible effect on refractive index. But the context of this is that basically somebody else has already measured the refractive indices of these elements, and it's confirming their previous measurements. So it really reasserts the position that refraction is negligible because it's based on a negligible claim in the first place. So negligible claim and then reasserted to be negligible for a second time kind of makes refraction negligible. And that's the second citation for that word. And this one's often affectionately referred to as the study by the school kids. This is, I think this is like what we would call further education, which is the it's high school, but not, it's beyond high school, but it's not university. It's kind of what we call college. And in this paper, there's like loads of maths and pretty diagrams, and it's really interesting, some of the stuff that's in here. But in terms of refraction, and actually seeing obstructions at horizons, it talks about, when I get to it, it's been a while since I've looked at this. There's so much I can talk to you about this one, but here we go, get into it now. This is all looking right. So this is the one that I always refer to. Basically, it says that for every object, there is an area that the light cannot reach. This area is called the vanishing zone, shaded in grey in this image. When the observer is located inside this vanishing zone, the object will be invisible to the observer as no light rays can reach the observer. We can find the vanishing zone using our program as well. So basically what it's saying is if the observer's here looking across, like wherever he's looking across, the light seems to like do this weird thing where it will effectively cut off the bottoms if you got a target in here somewhere, but it's partially in here and partially not. This is saying that it will cut off the bottoms of it anyway. But when I cite this, they always say, well, what's the values on the axes? And there are no values on it, but this is citing that for every object point, there is an area that light cannot reach. And it's just something to show that things aren't going over the curve of the Earth, because if there was a curve of the Earth involved, it would say for every object point, there is the curvature of the Earth to consider. And it doesn't say that. It just says every object has its point where light cannot reach. And in the context of like mirages and stuff, I mean, there's loads of stuff in this document, and it's really quite interesting because some of the explanations you just can't really make much sense of. But here's a good example of a Fata Morgana, right? But then there's the inversion again on top of it. It looks like it's coming in. So you got the boat, and you got the front of the boat flipped upside down, and then it looks like you've got another flip, but it's very squashed on the top because you can see the mast that's there, which I think is the mast from here, but being flipped up again. Rich, would you agree?
Yeah, could be. But just to point out, the Fata Morgana would be, if this was a video, this would be changing the whole time.
Yeah.
Otherwise, it's a superior mirage. If it remains steady, like in the video I was talking about yesterday, Chicago, you would just call it a superior mirage.
Well, check this. This is one of my.
You can get a third flip, which would rectify.
So check this out. This is one of my favorite observation points. This is looking across to the Irish Sea, to Isle of Man, and we can see two peaks, and we can see that the land tapers off to a point where it drops into the sea. Then we see a gap, and then we see some land, which we shouldn't see, by the way, from where I am. This land shouldn't exist, but it does, and they explain it away with refraction, where they bring back the tippy tops of it and claim that they bring back it all. Anyway, the point of this is just that's what we should be looking at. So we've got like a drop bit where it goes in, then we've got water, and then we've got this land on the other side. Now, if I show you a video of a really interesting phenomena, and I don't know what this actually is. All I can say is that this appears to be what they describe as looming, and it's really quite interesting because what they describe looming is that the horizon rises up before your very eyes, and they say that it's being brought back from behind the curve of the earth. So we can see here, if I pause this a sec, you can see that there's a thick band forming across the base of the mountain, and this continues right the way across the picture to the right. And as I go across the picture, you'll see that I'm hoping that you can see this, Rich. You might not see this thick band in at the moment, but you'll see it when it gets to the water.
Yeah, I can see that. I can see the demarcation line there.
Yeah. So when we get to the part where it drops off, which is coming up any second now, you'll see the land drops into the sea. And this is where it should drop into the sea. It should drop into the sea just there and stay there, and that should be it. But for some reason, this kind of carries on into the water, and that should just be water. But note where the horizon is. The horizon is this hard line here. That is the actual horizon or close to it. But look where the land appears on the right-hand side that is affectionately known as floaty land. The land appears to be on the top horizon, but not on the bottom horizon, and there's no inversion layer underneath. So I think this is actually looming, the way that not the way they describe it, but the way it actually is in real world, because that horizon that's there should be underneath. What do you think?
Yeah. Now, is this the same?
Yeah.
On the right side as you showed earlier in the other picture?
Yeah, that floating land, yeah. For some reason, it's actually above the horizon, and there's no trace of it underneath. It's not a flat Earth or a ball Earth proof. It's just something unusual that I've never seen before.
Yeah, can you go back again, left?
Yeah, I'll pan over now. It'll go back. You can clearly see that the horizon, for some reason, is being loomed above the actual horizon.
Now, see that layer before you get the land? That looks like it's a little inversion layer. When and if I ever do this myself, I can have a vantage point. I'm going to have observations done on both sides at the same time while I'm filming.
Yeah.
And maybe even radio sound data, which is a balloon going up and measuring the temperatures it goes, so you can tell if there's an inversion, or the local weather service. That would be the best thing. Find a city like Chicago, get their radio sound data at that hour. Make sure it's an hour that they're doing that. They should launch it every 6 hours minimum, I would think, anyway. We did on the ship every 6 hours. And that way you can tell if you have an inversion there, because when you went over and the land disappeared and you still saw that, fog is an inversion layer at the ground, at the surface. It's a cloud at the surface. But you see that gap there?
Yeah.
Go back just left a little bit. Yeah, that's good right there.
This gap here.
Yeah, you have what appears to be the ocean, the same color of the horizon, the sky behind it, then almost a fog bank.
Yeah.
But it would be fog if it was touching the ground. Otherwise, it's a stratus cloud. A clearing, which means that's the end of that inversion. Then you got another one. You have two inversions there, I would say. Once you get condensation in an inversion layer, it generally, the condensation stays for the entire layer. So it looks to me like I was describing, like it's getting warmer just above the ocean. It gets cooler again so that the clouds don't condense in that little strip in between. And then it condenses again. What I would say is probably you're seeing what you're not seeing because of that lower, let's call it fog, because I can see it's touching the ground at one point. That's probably where the actual land is on the ground. Then it's flipped once upside down. You can't see it because it's obscured by that fog, and you're seeing the smaller inverted back upright again at the top.
See,
that's what I would say by looking at that.
For me personally, I look at this and I think that this can't even happen on a ball, because the fact that you're getting a reflection above, and if there is an inversion and then another inversion again and it's back the way it should be, I don't even see how this is even possible on a ball, because it makes no logical sense to me. The only way this can work is if the surface of the water is acting like a mirror, and that's causing these inversions, or it's at least contributing to the inversions. Because I can't see any logical explanation for why this or how this would even work. It doesn't make any sense on a ball to me.
It doesn't make any sense if you can't see it in the first place. I mean, light has to strike it and come back.
Yeah. This idea of looming is not what they tell us it is. I mean, I don't know what this is, and I'm happy to accept what you say, but I'm also happy to say that this is probably looming, because this is the replacement horizon with a different horizon that definitely should not be there. But who knows? What do we know, right? There's no science for a flat Earth. We're kind of stabbing in the dark at it, but it's just an interesting observation that I noticed, and I just thought, ooh. So let me get off screen share. Oh, I believe that we're off it. Yeah, we're off. We're off. I'm not screen sharing now, am I?
No, it's all good. You're not screen sharing anymore, so that's all good. And I mean, it's one of those. As far as I'm concerned, the fact that you can get reflections means you need a flat surface. You know, none of this should be possible on a ball.
Yeah. We have the Rich. Did you see the physics teacher that gave me that exam paper to sit the other week?
I saw the teacher. I think, is that the teacher you debated?
Yeah. The other part of that deal was that I had to sit an exam paper and see if I could pass it or not live, and I did it and passed it. And to be honest, he gave me two previous papers as like warm up, and they were a lot easier than the one he gave me. But he's in chat now, and he's quite a decent guy. But he's a physics teacher, and he doesn't. He teaches the kids about the independent variable and the dependent variable. But when we try and push him on gravity, improving gravity, he can't get away from density. But he doesn't realize he can't get away from density. He keeps talking about vacuum chambers and things like that. And we're like, well, what about the gravity though? And he keeps saying things that are like, well, but there must be a force that's making these things go down. And I'm like, right, so can you show the force then? And he's like, no. But he doesn't realize that not being able to show the force is a problem. And that's the whole point. It's like the definition of Darwin's gravity is the attractive force between masses. So if you're going to show that there's an attractive force between the Earth, guess what? You need something the size of Jupiter to bring closer towards Earth and manipulate the gravitational pull from Earth to show that a wrench, when you let go of it, it'll go up. And unless you've got a Jupiter in your back pocket, you're not going to be able to do it according to the scientific method. But he doesn't realize that that's a problem. So he starts looking for ways around it. And at the minute, he hasn't found out one yet. So shout out to Al in the chat. I hope you find some proof of gravity at some point in the next few weeks.
I'm pretty sure you mean Einsteinian or Newtonian as opposed to Darwinian.
Oh, I keep doing that. It's because I had a conversation about evolution before, and for some reason I've got Darwin stuck in my head. But yeah, you're right, Newtonian. Apologies.
That's all right.
Yeah, I saw that debate. Yeah, he's I don't know. You can just tell, I guess. He's a nice guy, like the guy I debated. They're good people.
Yeah, he is. He's a nice guy, but he hasn't thought laterally. He's thought everything they've told him is true, and he's never challenged it.
Yeah, well, as soon as I saw the feather fall at the same rate as a bowling ball in a vacuum chamber, I knew it was density. Had to be.
Yeah, but that density, he can't get away from it. He still argues and starts talking about like different things in a vacuum chamber, and I'm like, yeah, but you need to be moving away from the density. Show that it's not density. How are you going to show? How are you going to manipulate that independent variable, gravity, to influence and affect the dependent variable, like the attractive force between masses? How are you going to do that? And you can't do it by virtue of the definition itself. But he hasn't sussed that yet. He keeps looking for sneaky ways around it. And I'm like, no. Manipulate that independent variable. Practice what you preach, son.
You know what I don't understand, and I don't understand this with gravity. At one point, does like the space station is supposed to be microgravity? They supposedly show things that float, and you see these different films of them. As soon as they leave the atmosphere, it's like all of a sudden they take their gloves off and they start floating. Where does gravity end and this microgravity start? Because we've sent things up, 130 some thousand feet, balloons, and they fall at the same rate as everything else, and they don't burn up from friction from the atmosphere, because all the atmosphere does is create resistance, not friction. So there's a lot of things I just don't understand in their model. I don't understand, because things at that height should weigh a lot less, but they seem to fall just as fast to the earth, which means they're attracted to something else.
That was something that Russian Vids brought up when he was on the Non Sequitur show. So he was saying that there is no footage of the actual transition, so you don't get to see them going into quote unquote space. You don't see footage of that. It's always cut to the cartoon, cut to the rendering, cut to the the internal guys looking at the desks, looking at the monitors, looking busy.
Absolutely, I've never seen it.
Yes, I agree with Mark Sargent when he's challenging people to find a spacesuit, get in a vacuum chamber, and show that you can actually withstand a vacuum inside one of those material outfits. And there's a guy who's got a father that's an astronaut. His name's M. Scott Veach, and he's the antithesis of everything that we are challenging. And he claims his daddy went to space. He claims that his daddy was a spaceman. And see, my dad was he's a retired police officer. And I can prove, if I had to, that my dad, A, was a policeman, and B, did arrest criminals. He's still got his epaulets, he's still got his handcuffs and all that kind of stuff as keepsakes, because you get them when you retire. Does it prove that he actually arrested criminals? No, but you wouldn't have these if you weren't a police officer, right? But how is that any different to a NASA guy with an astronaut outfit? Doesn't mean he went to space. But if I had to, I could get evidence, so I could prove that he actually, he's got stuff that would prove that he went to court with criminals. There's just bits of paper knocking around that shouldn't really be at home, but you end up taking them home and then forgetting about them, and then they get filed away in the attic somewhere with a load of bills and all that kind of stuff. There's just paraphernalia knocking around of his time in the police where I could prove that he was actually a policeman. But if you go to M. Scott Veach and say, can you prove that Daddy was in space? The answer is, well, no. I was like, well, how do we know that he was then? And I accept that he might have been an astronaut, but no astronauts have been to space, and he thinks that we're ridiculous. And I'm like, well, prove it.
So he should have access to a spacesuit, or be able to put us in contact with one, I would think.
Yeah, that's what I've tried. He's been challenged to do that. He's agreed that he will do that, and he's going to try and get a vacuum chamber with a spacesuit. And Mark Sargent's basically said, like, if you go in there first, Mark presses the button, and then if you come out there alive, then
I suggest we put a frog in the helmet and just watch what happens.
No, I said we put M. Scott Veach in there and see what happens.
Who?
M. Scott Veach's name is.
Oh, I don't know him.
M. Scott Veach. He's just a guy.
Oh, okay.
But it's good though, because basically, if M. Scott Veach comes out alive, then he'll go in.
I dare say nobody's going to voluntarily go in there.
Yeah.
Because when it comes down to it, are they really sure? I don't think so. And we have the one video, I'm sure everybody's seen it, where the one time when the guy had the hoses hooked up, which is a lot better than internally the suit trying to keep pressure. You have external hoses pumping in air to keep the pressure up, and sort of like jet engines constantly forcing air inside the plane that you're in. But that guy, they didn't get close to the vacuum of space, and the guy starts to pass out, and his spit on his tongue started to boil.
Yeah, that was because one of the pipes popped off, right?
I don't think the pipe came out at all.
That was the cause. One of the pipes came dislodged, and it started to leak the air that he was breathing into the vac chamber, which was then being exhausted out. And it normally takes them about 23 minutes to repressurize the vac chamber. They managed to do it in about 6 minutes because they burst the seals to get in there because the guy was dying. well, that makes you think, well, what's the risk assessment going to be for sending an astronaut into space if when they were testing it in a vac chamber, the guy nearly died? Because, I mean, you get a micrometeorite, and if it goes straight through, I mean, if it doesn't take out your arm in the process, if it just catches and grazes your suit, you've got a major leak there. What are you going to do about that? You're going to die. You are literally going to die if it's anything like what they tell us it is. But it just, I just can't see a risk assessment ever saying, well, what are the risks? Micrometeorites. How are you going to prevent the risks from being a problem? Well, there's nothing you can do because there's nothing that'll deflect them. They say the suits do, but they don't because they're traveling at ridiculous speeds, apparently. And then even whatever the risks were, whatever the risk assessment was, and could you do anything about it? It's like, is the risk worth taking? And it's like, well, I don't think anybody would actually pass a risk assessment if you were in NASA trying to send astronauts into space in a spacesuit. The risk assessment alone would be a massive lawsuit in itself.
Yeah, and what's funny is right after that test, they immediately went to training in pools instead.
Yeah.
Water.
I like that astronaut that nearly accidentally drowned, and he was supposed to be in space at the time, and his suit started filling up with water. It's like, really? Did they have water up there, did he?
Well, you know what it is. The cognitive dissonance is so strong. Remember the guy drifting by in the harness? You know,
yes.
Oh, that's him exercising in space.
Oh, come on.
You know,
that doesn't really narrow it down very much, does it? That guy floating by in the harness, that's basically all of them on the ISS currently.
Yeah.
Yeah. He just happened to be his harness wasn't green screened out or layered out, whatever it is.
Really?
Hey Rich, I want to show you something that Ranty's been working on recently. Do you mind sharing again, Nath?
Yeah, can do.
This is the hot topic that we're dealing with at the minute, right? Let me know when you can see it.
Yeah,
I got it.
So this is 2 sets of turbines, right? The first set, the nearest set, the biggest set, I believe. Oh, hang on, no, that's not the most up to date. Hang on, let me get the one that's most up to date. There it is. No, not that one. Let me get it. I'm just trying to remember. Right, what I'll have to do, because I'll have to go into my Skype. I'll have to knock screen share off a sec. Go into my Skype, retrieve it, and then come back to it. So, where is he?
I sent you the most up-to-date one.
I know, but I'm just trying to find a link. Here we go.
While you find it, where's it from? Where's it taken from?
It's taken from Blackpool. Basically, it's right near Blackpool in England, and it's looking up the coast northwards towards Barrow-in-Furness, which is just another coastal town. But it's Ranty's work, and it's probably the best flat Earth proof out there at the minute.
While you're looking for it, just so I'm distracting for you, so you can be covered. So he's looking at Ormond offshore wind turbines and Barrow offshore wind turbines, and they're at differing distances. You got it up? You ready? Yes, it looks like this is the one. Excellent. So the ones in the near foreground are Barrow, and these ones in the background are Ormond. Do you want to? You can do the honours, Anthony. Go ahead.
13 miles for the first one, 15 miles for the final one over on the left-hand side. But then you got 21 miles on the right-hand side back to 23. Now, there's numerous things that are wrong with this in terms of if we live on a ball. But what the ballers were saying is that if you look at this black collar that's around the dirty water part of this, you know, where the tide goes up to and down to or whatever, they're saying that proves that it's the curvature of the Earth because it's clearly going over the curve of the Earth. And, you know, on first views, you can see that argument has got some credibility towards it. However, if the turbines are going over the curve of the Earth at the bottom, they've got to be going over the curve of the Earth at the top as well. And it's a dead straight line going straight through these, and it's a straight line going straight through these. Now, the problem with the straight lines is, of course, if it's on a ball, when you get to 21 miles away, there's a curve that should be passing between these turbine heads. And it's flat. It's straight lines, straight and flat, right? But their argument is that, well, the discrepancy is so minor at that distance that you can't tell it. So in other words, a curvy line is actually straight. And me and Nathan are like, absolutely no way. That's not the way it works.
Well,
so that's one of the arguments that we've been having.
Hold on, you
missed
a bit.
They apply it to the bottom but not the top. Is that what you're saying?
Well, no, Anthony's missed a bit, the crucial bit. So,
well,
let me just take over. You've dropped the ball there, Anthony, so I'm taking over, mate. Right. So we've got.
I was leading up to the crescendo.
Oh, go ahead. I'm sorry.
My bad.
No, it's okay, Nathan. You do it, Nathan. Go on. It's okay.
Okay. Right. So you've got near ones and far ones, and obviously the curve calculator gives you a squared function, i.e., the further out you go, the more curvy curvy it gets. So the ones in the background at 23.6 and 21.4 miles should be curving more than the ones in the near foreground. But they're not. They're exactly the same angle. They're conforming perfectly with perspective, despite the fact that they should not only be curved to at least some extent, and they're not, but they should be not exponentially. They should be curved more on the back ones than on the front ones, because they're already suffering the effects of the curve that's in the near foreground between us and them, and then their own curve based on their geographical position on their own curve. So you have this adding effect of there being more curved the further you go out. It's a squared function. So you should see them curving more in the background than you should in the foreground. And instead, you can see Anthony now doing it with the line, that they're the same. You know, you're just seeing the effects of perspective. That's it. Anyway, sorry to steal your thunder, Anthony.
No,
sorry.
It goes one step further, though, because if these close ones are following a curve, the gradient of the curve, you know, the arc of the ball that they're supposed to be following, cannot be the same as the arc that these ones are following, but they overlay perfectly. Now, again, their argument is, well, it's such a slight amount that you won't notice it. But the problem is, if these two lines are parallel between these hubs, they can't be curving over at a different gradient, because these are perfect. I mean, I'm trying to overlay the lines that are here now, and I'm not quite perfect with it. But the parallel, now they can only be parallel on a plane. And what we're seeing here, because it's a straight and parallel line, we're seeing perspective. We're not seeing any curve, because perspective is linear and curvature is the opposite. It's a curve. So basically what they're saying is that, oh, well, it's such a small amount of curve that you can't actually see it. Well, all right, then let's give them that just for the sake of moving on. Explain why the parallel. Because it can't be parallel if one of them's closer to us and the other one's much further away. They can't be parallel, because one's supposed to have a steeper gradient. So the one that's at the back should be more like that. Do you know what I mean?
Oh, yeah, I got it.
But they can't have that. They won't. No, they'll say, oh, it's the same, but it's just, you know, it's just
again. I'm really sorry. It shouldn't be like that. It should be curved. And there is no curve there. I mean, they're all in a straight line. So Ranty said this earlier today. He was like, well, the line should be like this. It's like, there shouldn't be a line. You know, it should be a curve.
It should be a curved line. You're right. And it should also change the orientation of the line, because it can't be parallel. Just cannot be, because that tells you that they're in the same distance away, but they're clearly not.
Yeah, it should be a steepening arc.
Yeah, it should be an arc, and it should be not in the same orientation as the first one. So it's twofold. It's the fact that they're not curving, and it's the fact that they're parallel. And the only way they can be parallel is if we live on a plane. It's the only way. So who cares about the bottom? We know that the bottoms. We also showed. Do you remember Good Times for All, Rich, with the warehouse observation where he went further and further back, and the paint tins all merged. All the bottoms of the paint tins all merged.
I think I remember that. Yeah.
That's basically what we can show with these. We can recreate what's happening with these, because, like, if you look at the band here, the band is like a thin black line, thin black line, thin black line, thin black line, getting fatter. Big fat black line disappears through the curvature of the Earth, and then there's no black line at all. But what's actually happening is it's like someone stretching, smudging it down the page. And that's exactly what Good Times for All showed. And it's something to do with the angle. When you get the angle, the top's coming down towards the horizon, but the bottom can't go any further. So it starts to merge and converge, and that's perspective again. But they all claim that it's the curvature of the Earth. Well, if it is the curve of the Earth, then it has to be matched by that which is on the top, and clearly doesn't do it.
That's it. Yeah, you can't apply it to half of it, not the other half.
Yeah, it's curving at the top as well, guys. But then, John,
this is an ad for a project manager.
What?
That's just me getting Good Times for All's video queued up, so I can just stick it on screen. Sorry.
Yeah, stick it on in a sec. Yeah, I'm just going to read what he says here. You can't have linear lines perspective, because we know that Ranty showed that he got some street lights of like lampposts of over about a mile, and he showed that they have that straight line linear relationship over just a mile, and we see the same linear relationship with these. So what we were saying is that this is perspective that we're seeing, because it's a line, it's linear. It's not curvature of the Earth, because it's not a curve. And their argument is, well, it is a curve, but you just can't tell. It's like, all right, well, let's just say it is a curve. Why are they parallel? And you can't get past it. It proves flat Earth. I'll give way to Nathan.
Yeah, that's excellent. Really is.
I'm just going to leave it to play with his images, actually, so it will just be.
You might have to click his link in the thumbnail in the chat, Rich.
I've done it. I see it.
Yeah, I've hopefully queued it reasonably well, so we'll just go into the snapshots at this point and show, the miraging that you were describing at the beginning of this show. I thought I'd play it from this bit because it actually shows you his setup as well. Might as well have it on this. On a different note, I'm hoping to speak to Zach on a completely unrelated topic. I'm hoping to talk about psychopaths with him. I think he was on Iron Realm Media recently, or just on a Skype conversation with us, I forget which. But yeah, with some of the guys from Iron Realm Media that released. But yeah, he was talking about psychopaths and was very, very clued up about it, so I'm hoping to chat to him about that as well. On a slightly different note, on a tangent, but yeah. In the meantime, back to this. Hopefully he's going to cut to the photographs in a second. Spin on and see, yes, it's about here-ish. Okay. It's going back in, what is it, 20 feet increments. Showing this band that starts to appear about here, about 100, 120 feet. And then you see that the horizon's dropped and miraged, if you want to call it that. There's a reflection layer, there's a fold line. But the actual horizon he keeps highlighting with this blue line. And when he gets to about 220, 230 feet, you can really see the effect starting to get a bit more dramatic. Okay.
Yeah, so that's already what we see with the at sea videos.
Exactly. So at this point, I'm going to say we're starting to lose the bottoms of these paint cans, or paint can lids. And it's starting to blend in with a mirror image of itself below itself. So with the wind turbines, you can't discern that. It's not like it's a paint can with, an edge that you can discern. So it just looks like an extension of the wind farm itself, the turbine pole, with a new horizon.
You ever seen the videos of the wind turbines as they come down and look like they touch the water? They all of a sudden reach down.
Yeah, they bend and
touch
morph.
Yeah, that's exactly what this is showing.
Yeah, exactly. So as they rotate, they reach that band where they are in that narrowest of narrow angle, and they can't do anything else but go into this mirage zone, and then you see them buckle, bend, come back out of the mirage zone, and then become normal again.
That was a good demonstration.
It's worth saying as well that at the very end there, all he does is he stands up in a normal upright position and takes the same picture, and all of it goes. So it's something to do with the angle. But again, it goes to show that, well, we can recreate these optical effects on a short scale, like a local level, without atmospheric effects. And if that's what we can recreate, then does that prove that it's the curve of the Earth that we're seeing, if we can recreate it? It's worth doing the Soundly one as well, Nathan. The Phuket word one.
Yeah, if you can grab that. I don't know where to get it to hand. You probably know the title off the top of your head. If you can bring that up, I'll just take the screen off you so you're not frowning while you search for it and stuff.
Yeah, okay.
Have you seen the newest videos that people are doing showing how we actually see because of the shape of our eyeball, and how what we just saw, the bottom part will scrunch up faster than the top when we look at the horizon or whatever. And it's a lot of it has to do with how our eye is shaped and how we look out at the horizon, whatever. But the way our eye is I shouldn't say trained, the way it is formed, the angle is slightly different at the bottom of our field of vision versus the top. And it makes the lines converge faster at the bottom than at the top. This is why we can see planes go on and on and on before they get near the horizon, but a ship will appear to disappear faster at the bottom. A lot of it has to do with the anatomy of our own eye. It's fascinating stuff. It's long what they're doing as far as like their hour-and-a-half videos, but it's good stuff.
The same principle applies to a plane than anything else, in the respect that if you've got a plane going towards the horizon, i.e. travelling away from you, it will eventually still reach that band of the narrowest of narrow angle, i.e. it gets closer and closer to the horizon. It's not because it's travelling anything other than straight and in a flat manner, but ultimately speaking, it's like, I think the analogy I gave the other day was if you were at the the top of a 6,000-foot mountain and you park the plane on the top of it, it doesn't take much to imagine or envisage going backwards and seeing that mountain getting closer and closer to the horizon. And the same principle applies for the plane sat on top of it. Eventually you'll reach the point where you've only got the very top of that mountain, then just the plane, then nothing. And that's the same principle if it was flying. You can just remove the mountain from that equation or that analogy, and you've still got the plane reaching the horizon and then going into that narrow band and then disappearing. But I'd never considered what you just said about, the top half of your eye basically giving you, I don't know if resolution's the correct word, but a better angle to things that are basically above you in the sky. And it's often demonstrated in some of Ranti's images that he shows, because he's got maybe an inch or two in some instances between him and the convergence point, the horizon that you see in the picture. And you've got, like I say, 2 inches, 3 inches, a foot represented in the bottom half of the frame. You've got this really wide angle going into the midpoint, but above the midpoint you might have a mountain, hundreds if not thousands of feet in terms of what's represented in the top half of the frame. So it sounds like, from what you're saying, the actual eye itself will work in that manner, like we see some of these very low elevation observations presented to us.
Yeah. Now here's a hypothetical question for you. This is for when I go on my trip. Let's say an airplane is at 30,000 feet and it's right where that sun is, near the horizon right now. If it was to turn around and shine a very bright light at you, would it be above you, or would it come right to you because it appears that it's lower?
I don't know. I guess you're gonna have to test it.
Yeah. Well, the idea is the person I debated who believes in the heliocentric model, he wants me to show when the plane is level and when it's sunrise or sunset. I'll be getting sunrises only at the times of my flights. He said, look, when the sun comes through one window on one side, the plane's level, the image on the other side where it's on the other windows is higher than where you are, meaning showing that the sun is below you. But the question is, assuming that's true, is it in reality lower, or is it because it appears to be lower? I don't know that answer. I'm not that artistic to inclined to be able to tell. Maybe it's like if you had a 3-mile long tunnel where train goes through, so it's level, and you put a light at eye level and walked it to the other side at the same level and flashed it back at you, would it appear to be lower? The light, the actual light that hits you, would it now be lower than where it hit when it was right in front of you?
Yeah, absolutely.
Or pointing up.
It's going to get closer to the horizon, right? Further away you get from it.
Yes. But it's still, let's say you put it at 6 feet. So it's shining directly in your face. And let's just say it's a narrow beam. And you take it 3 miles to the other side to the convergence point, which appears to go down, and you shine it back at you. Would it then shine above you, below you, the same height? I don't know.
I don't know.
I think it would still shine at you, but from your vantage point, you would see it appearing to drop.
But going back to the airplane example, if you understand what I mean, the light comes in one window, and on the other side, it actually, instead of perfectly mirroring on the other side like it was parallel or even higher, you would see the light lower. The light hitting the wall around the window is what I'm supposed to measure. And if the light is above it, that's supposed to prove that the sun is now below you.
No, I'm not so sure. Well, I reserve judgment. If you do it, great.
Yeah, I hope I catch it. Now there's I'm doing I got downloaded a theodolite app, and I'm going to be doing 2 things because there's people showing at 35, 40,000 feet, a 5 or 6 degree drop or whatever they're showing, 3 to 5 degree drop in the horizon. But you have to tell if the plane is perfectly, straight and not banking one way or another by a degree or 2. So my son, the one who's a globe believer, he's coming with me on this trip, and he's got the same app, and he's going to be verifying the plane is level at the same time as I'm taking it out the window. So I'm going to be doing that as well.
How can the son of Mr. Thrive and Survive be a ball earther?
Well, I've got one that's a flat earther and one that's a ball earther. Actually, you know what? I think he's sort of moving off to maybe considering it. He's at college, away at university, so he doesn't get exposed to me too much. But he will be on this trip, that's for sure.
What's he studying?
It's computer engineering with major in, I can't remember, it's a specific one,
right?
But it's basically computer engineering.
Do you want to share my screen, Nath?
I can.
Let me know when you can see it, Rich.
You're on.
So what's that supposed to show? A 30 mile radius of the Earth?
Yeah, but we live on a basketball according to this guy. But I mean, we've all seen these pictures before, and like everyone's got a view on them. But what I wanted to pay attention to is the way that that these concrete base block things that the pylons are sat on. Look at how they bend over this apparent curve, but then lip back on themselves. And then relative to this lipping back on itself, look at the horizon. The horizon is significantly lower. Now, he's claiming that this is the curve of the Earth, right? But Nick from Phuket Word, he was able to reproduce this on the top of a dam. So this is a road across the top of a dam, which everybody accepts that water on a dam on a short scale is flat, at least to the observer or to the eye. But what he shows is that when he's low on the ground, you can see this same layer, the barrier bends back on itself, and the horizon appears to be low. Now, when I show him changing his elevation so he stands back up again, watch the horizon rise again and the formation of this Armco barrier that carries on into the distance. And clearly we can't see it at the moment, but when you see it in a minute, right before your very eyes, God creates an Armco barrier and a new horizon. So we can recreate what Soundly shows on a flat road. There you go. But they dismiss this. They just don't even consider it to be anything like. They say, well, that's on a straight road. Don't do it over water. And we're like, but we can recreate the exact same effect with a flat road, right? And they don't think that it's comparable because it's not over water or it's not the same distance but they just blatantly they just reject it. And it's like, you can't reject this. This proves it's the exact same effect that you're looking at there.
Absolutely. Now, how far away is supposedly those last pylons?
18 miles maximum. I think it's 17.8. So it's not even that far, really. And look at the amount of curve that This is what my first ever reaction when I first ever saw this. My first ever comment was, "So we live on a basketball then?" And that's still my position. It's not changed, because if this is the level of curvature over 17 miles, I'm sorry guys, but when we've got like 23, 24, 21 and 23 miles, we should be seeing that same level of curvature, but worse, and we're seeing it flat. So if you accept that this is the curvature of the Earth on Soundly's, well, why are we not getting it? We're going further. It's ridiculous.
Yeah, that I don't know what you would call it, but that's an illusionary thing.
Optical, we call it optical.
Yeah.
But the fact that we can recreate it means that it can't be the curve that he claims it is. But the amount of people that just accept it, it's almost as if they just they don't want to challenge the official authority, the official story, and if there's a bit of evidence that looks like it might support it, they'll just accept it. It's really bad.
Have you ever seen Robert Forth's work? He does a lot of photography. He shows the clouds behind and in front of the sun, which tells me, again, we don't see the sun directly. But anyway, he was doing a live video one day, and he was on the Florida coast, and he's pointing everywhere to the buildings, out at sea, different things. And he makes this comment. He says, I don't try to get the water when it's, because the beach is slightly out, you know, how the beach goes up a little bit, and then you have the hotels. He said, because if there's any kind of tilt at all, you get a distortion in the reflection of the water. And it was like, oh man, you just said a mouthful. You know how you see these nice reflective pictures of things that are miles away in the water, and it's a perfect mirror reflection. Or how about the flats in Brazil, or wherever that is, in South America?
The Bolivian salt flats.
Yeah, that's it. Bolivian salt flats. No distortion whatsoever. Total perfect mirror reflection, which would not happen if it was a curve. You'd get a distortion.
Got it on screen. Click on my icon.
Yeah. Look at that. Beautiful. Have you ever seen the pictures of the stars like reflecting and not all the stars reflect?
I was going to say that. Yeah. Chris Monk showed that one in
Yeah, man, that's amazing.
If you get a really sort of flat lake that's got no ripples on it and you look at the night sky reflecting in the water, not all the stars reflect for some reason. And the idea is that not all the stars are lights coming towards us. Some of the stars are lights going away from us, and the lights we're looking at the underside of the star, not the front side of it that we normally expect to receive.
Yeah, and it's not the darkest stars either. Some of the brightest ones don't reflect. It's really weird.
Yeah, it's madness. So what have you been doing recently? I've not seen anything from you for months and months and months, and then all of a sudden we've got Thrive Porn. We've had about 8 videos in a week. Or what's going on?
Thrive Porn, I like that.
yeah, loads of them.
Well, when you're laying in a hospital, you got a lot of time to think about what you want to produce, I guess. So I had a heart attack in May. That wasn't the worst of it, but as soon as that happens, then you're tied into making 10 appointments to see doctors and follow up and getting imaging and all kind of stuff. So that took a while. And then the medication they put me on, I have normal to low blood pressure to start with. But just like any other science, it's pseudoscience, like the term you used earlier. They assume, like both times I had a heart attack, the patient presented himself with severe chest pains. I never had one chest pain. But they're so used to the normal bias, they can't get away from it. I actually had them take it out of my chart on the computer. No, back pain, not chest pain. Because, it's like people should know there's a certain percentage of heart attacks where you don't have chest pain. But it's way distorted because they're so used to what they're told. It's always chest pain, so put it in there. And I even had a nurse where I told her I did not have chest pain. And when the new nurse came on, I heard her tell the new one, yeah, he came in with chest pain. I'm like, oh my God, it's like, go order a cheeseburger, what's normally a cheeseburger without the cheese. You got about an 80% chance of still getting the cheese. It's just this normalcy bias. But anyway, after that, you have all those things going on. He puts me on blood pressure lowering medication because that's what they do. You must have high blood pressure. And went to the gym. I'm rehabbing an issue on my shoulder. And before I knew it, I was seeing spots before my eyes. Everybody talking to me, it was like they were speaking Russian. I couldn't understand them. And they called paramedics, and they could not get blood pressure on me at all for the first 3 times. I was almost like a dead man. The machine just wouldn't do it. So they manually did it. And the first time they got a blood pressure on me was 79/35. So I nearly died from the medication, more so than the heart attack. So then I had to go work through that too. It took a week to get me off the meds. Of course, I stopped them anyway.
Was that? But when you said you were like people were talking to you in Russian, was that like hypoxia? So you weren't pumping enough blood to your brain, and you were just basically oxygen starved? Is that what was happening?
Exactly. That's exactly it. And I know, because I've been in the medical field, I know they should have laid me down and put my feet up. But I wasn't cognizant enough to tell them that. Finally, when just before the paramedics walked in the door, somebody knew that and said, "Hey," and they kicked a little table or something down there. It's a gym, so it was some kind of workout thing, and they were like, "Have him lay down and put his feet up here so blood gets to his brain." And just when they did that, the paramedics came in, so I didn't lay down. But that was the right thing to do. But yeah, so that's really what I've been doing, is fighting medical stuff. This shoulder area, it's really bad. Believe it or not, I think it might be a military service related issue. I'm going today in an hour and 15 minutes. I got to be there to get a CT scan of my neck and spine. I really bashed my head big time. I'm sure the trolls will love hearing that. When I was in the Navy, got 23 stitches here. They said my neck muscles were way sticking out. They really thought I had severed my spinal cord. But a few years after that, I started getting migraines. I just attributed it to my mother got migraines, so it was hereditary. But I've had other issues that I haven't really connected until recently. Till the last doctor I saw, I finally had a good doctor. And she said, "I bet you've had some sort of trauma to your neck." And I remembered that thing because my neck went straight back like that when I got that gash on my head in the Navy. And anyway, we'll find out. But it's just a lot of dumb medical stuff that I have to go through. So that's a lot of reason for the emptiness there. There's other reasons too, but that was a big part of it.
Gotcha. I muted you, Anthony. You were just causing a bit of feedback, just in case you're unaware.
Tell us a story about how when you're in the Navy, when you were in the Southern Seas, you always found that it took way too long to get to where you were going, and you'd have to do boxing.
Yeah, when we were 2 times, one time we went to South America, and let me throw this point in here too, because people are always saying that if the Earth was a ball, if the Earth was flat, you could hear AM radio for 1,000 miles away. Well, I'm a Baltimore Oriole baseball fan, and in 1983, when we were going to South America, we were in the World Series when Game 1 was on. So this is October of 1983. We were just passing the equator. Of course, our ship was listing up, going over that 7-mile bulge, and then we got topped out and went down the other side. Just kidding. But anyway, I'm on the radio. Our radio, we used to get the weather stations reporting from wherever near where we were to plot on the chart. We could tune those, and I would tune it to AM 1090, which is WBAL in Baltimore. And 1,500 miles away, I think is what it is, off the coast of Brazil. I listened to every part of that game except for the last out. And when it was a fly ball to left field. The left fielder goes back to the wall, static then. I heard 26 of the 27 outs, 1,500 miles away on AM radio. Didn't think anything about it, of course, at the time. There were so many things that I didn't think about at the time that now I'm like, oh, Flat Earth explains that. But one of the things was even South America, from the time, South America, if I can do it right for the camera, when you're going down to Brazil, there's a part that sticks out farther east. No, it's the other way. Further east like this, and then it goes down, then you hit Brazil. Well, from the time we hit that corner down to Brazil, it was like, are we ever going to freaking get there? That was one thing. So we go out, and then you have to come back in. So you have to go more of a lateral east-west. It's more southwest, but that was one thing. But it wasn't that exaggerated. But then we went to the Suez Canal. We went to Mombasa, Kenya. And when we left Kenya, we were going to Australia. And it was pretty much a straight line. And we did purposely stay near Diego Garcia for a couple weeks. So, and I'm plotting behind. We always knew where we were. But then we headed back headed towards Australia. And on the 60th day, they gave us what's called a beer day. It's the only time in the Navy back then. I don't know if it's changed now, but if you were out at sea 60 straight days, you got 2 beers. And of course, everybody was negotiating. The alcoholics were giving you $50 for their tickets. But anyway, so we had that. And then it was still like a month before we got to Australia. And it was like forever to get there. And then coming back was the same thing. We didn't stop anywhere coming back. We went to the Suez Canal, and it just seemed like it took forever. Whereas we could go from Norfolk to the Straits of Gibraltar, that's the east coast of the United States, Straits of Gibraltar, in like 3.5 days. And when just past, we were between Italy and Spain when the Lebanon bombing happened. This is earlier, I think 82. And in no time, like 18 hours, 20 hours, something like that, we were off the coast of Lebanon. But for some reason, in south of the equator, everything seemed to take forever. It might be my perception. I wasn't looking for it. We got little slices of Mercator maps generally that we plotted everything on. The only time we had big expanses was like when we were crossing the Atlantic. We'd still have the east coast of the United States and the Atlantic and just the western slice of Africa, maybe England. And we had these little small, it was really too small for any length of time for forecasting. So then we went to larger, but they were always Mercator maps. We always went in a straight line on a Mercator map when we were rushing somewhere. And we were always rushing from Gibraltar back to Norfolk to try. There's a record that every carrier tries to break. At least back then, people say, that's not true. I was on a carrier last year. Anyway, we always try to break the record. And we didn't follow any great circle route to do it. We went in a straight line on a Mercator map, which means we were not taking into consideration a curvature of the Earth. So But like I said, we had slices at a time as we went across. We didn't have the whole big, we didn't have Africa to Australia. So I couldn't say, wow, this is really taking a long time. It was too condensed. But anyway, yeah, that's one of many things I think back now. I want to say, why didn't I question that?
One of the official reasons for why the Titanic, quote, Olympic, sank that night was one of the reasons was why they didn't see the iceberg that was dead ahead was because of the refraction. Apparently, at certain times of the year when it's icy weather, the horizon, you can't distinguish the horizon from the water because it blends into one and you just can't see the horizon. And I always found that interesting that refraction was actually one of the official reasons. Whether it's true or not, it's irrelevant, but they did cite it as one of the official reasons for why they couldn't see the iceberg dead ahead because of this weird atmospheric effect at the time.
Well, that's interesting because I believe that was at night when they hit that. So it's interesting they were talking about refraction. Maybe it was like the mirror image we're talking about, the stars and everything. I don't know. You know, the latest I've heard is that there were 4 people on that ship who were bigwigs in the world who were against the formation of the Federal Reserve Bank.
Yeah,
and that they actually blew that ship up. Dynamite or whatever in that part of the ship so that those people would die, and they all 4 died.
Yeah, I've heard that it's an insurance fraud job because it was the Olympic that went down, not the Titanic, and the Olympic had an accident in as it was pulling out of harbour somewhere with a destroyer, and basically as the captain was powering up and getting the turbines spinning, or the blades spinning, it had a suction effect with an oncoming destroyer. And it basically started pulling it towards him, and the destroyer couldn't get out of the way. And it caused damage to it that would always mean that the boat listed to one side, and it'd never get a seaworthiness certificate again. So basically, they had to get rid of it, and that's what they did. That's the one I tend to accept to be true. It was an insurance claim, but it's all good.
Yeah, I've heard it was heavily insured.
Yeah, like 9/11 towers were, right?
Yeah, yeah, like what was it? Building 7, World Trade Building 7, insured for more than what it was worth.
Yeah.
The only building ever to fall on its own footprint with nothing hitting it.
Yeah, they all forget about that, like Building 7, they say, and I don't think they do forget about it. I think that they say that so that people forget about it. But Building 7, yeah, not hit it. Yeah, it fell in its own footprint of basically free fall speed.
Yeah, there's no bigger smoking gun than that. But as we know, there's cognitive dissonance. You know, when I first started Flat Earth, some commenters were like, "You're only doing this so you can switch to the lies of Flat Earth of 9/11," meaning that I was going to say it was a hoax, and that this was the intro drug, so to speak, to 9/11.
Oh, right. When I started, I was hearing you're muddying the waters of 9/11 conspiracy truth.
Really?
Yeah, muddying the waters.
Yeah,
I heard that a lot.
It is funny how the cognitive dissonance will send them both ways. Like I said, after I did Snell's law, which is their science, not mine, it's their science. I got massive, I mean, probably the worst vile comments I've ever gotten. Everyone was trapped, but half of them were saying, "You're such an idiot. We don't look at 0 degrees. We look up when we see stuff at the horizon." And the other half were like, "No, we look down." And some people were like, "You effing moron. If you got down on the ground and looked at the horizon, that's the way you have to do it." I'm like, "Oh man, just forget it." Anyway, it was easy to just click, 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 ban.
Oh, Anthony can recite at least 2 or 3 of those back to you in exactly the same format, because that's exactly what he's got. But by virtue of one of the trolls, so I'm sure you're familiar with, Sly Sparkane, I mean, he basically challenged Anthony to go down the beach because he wouldn't accept one of the I can't remember the exact circumstances, but nevertheless, he was challenging him to get some of the footage he'd already got from the beach. And what do you know? He gets it. You know, it's like, oh, thank you very much.
It went one step further, though, because when I went back to the beach and got it at beach level, he said, "Well, what about, where's Ramsey?" And I was like, "What do you mean?" He's like, "Well, you can see that, but what about this?" Which is like in the frame, but it's a little bit lower. And I was like, well, waves are a bit of an issue when you're getting really close to the horizon. When you're bringing it right the way down to basically 0 degrees, waves become an issue. Anyway, he says, "Well, where's Ramsey?" So anyway, I went back another day and I got Ramsey. And when I presented him Ramsey, he was like, "Huh?" So my claim was that Sly can't answer this question. And because it had history to it that went over 6 months, I had to tell his subs on his channel what the history was. And I said, like, this is where we got to. This is how we got to it. Da, 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 da. And ultimately, I got to the point where I said, Sly cannot answer this question. So I got to the point where I presented the evidence, and I said, this is the point where you cannot answer this question. Why can we see the land? And literally, his next words were, you're not going to try and use a mirage, are you, to try and reference heights? And I was like, what do you mean use a mirage? And he was like, that's a superior mirage. And I'm like, there's no evidence of it being any mirage. It looks like it's been squashed, but doesn't look like it's a mirage. What are you talking about? And basically he says to me, do you think that you can use that to reference heights? And I said, yeah, of course. We can see two mounds of earth in it. That's one. There's the other. We see the height of one. We see the height of the other. Seems reasonable to me. And he kicked me out on that point. So he stood by my claim. Sly cannot answer that one question. Why can we see it? He found an angle to try and kick me out. And whilst we were on topic, we weren't fighting. We weren't losing each other's tempers. We were literally talking. He kicked me out because, well, basically he didn't agree with me pointing out the heights of these, because it kind of destroys their argument that there's a curve there. And he literally kicked me out. And I was like, really? You're going to kick me? And he actually kicked me, which is essentially
terrible argument. And in the face of everything we see, in essence, in the heliocentric bullshit world of sphericity, everything we see isn't where we think it is. It's all being subject to refraction. You know, it's all bending around the curve of the Earth to some degree or another. So everything's a refraction. Everything's a slightly looming non-standard refraction hyena. It's absolutely bonkers to say you can't measure that. It's like most of the debate, we've been measuring things we shouldn't be able to see. It's like, well, really? We get enough of your side measuring stuff that isn't really there. I mean, we see it. Obviously, it is there. We can see it. But it isn't really there because the math says so. But we measure that stuff all the time. Yeah, that's his excuse to kick you out. It was an outrage.
Yeah. It was great that I got kicked out, actually, because it just showed that he couldn't answer the question. So, I mean, it was, to be honest, it was the least probable outcome that I thought might happen. I didn't even consider it as an option. But to be kicked out of Sly's hangout when I wasn't swearing, I hadn't felt like I wasn't being rude, it wasn't aggressive. I was just bang on topic and I was right to the point, and he didn't like it. So he had to kick me, and I was like gobsmacked, and I was like, Nathan, what's just happened? He normally concludes points, and even if it's a 50-50, he normally claims a victory and claims in his smarmy way that somehow he's won there, and somehow you feel robbed and you don't quite know what's happened. But I didn't even get that. I just got kicked and I was like, bye. So, I don't know, it was enjoyable for all the wrong reasons.
Cool.
So,
Rich, you got anything else? Anything else we need to be discussing? If not, I'll start wrapping up if you guys are happy to.
Well, I believe that Rich said that he wants to have a bit of an interest or a bit of an interaction with the actual debates that we get up to at some point. Maybe not now, maybe next week or maybe in a week's time, but he wants to get involved in the debates. And I said, well, why don't you just come in and just sit and watch if you want, because it can be a bit vicious at times. But to be honest, none of the ballers come in anymore, did he, Nath?
They might come in if Rich came in. I'm sure they'd want to tear a few chunks out of you, Rich, if you did happen to join.
Yeah, well, I think we just finally got the hours right today, what it is. I was going to join this morning, but my air conditioner broke in my truck, and I had to go get it fixed before it was 40 degrees again and middle of the afternoon. So I got that done. And now I had the hours wrong by 2 hours. It's so confusing because here in Arizona, we don't switch our clocks at all. So when everybody else switches, and we switch our clocks in this country different than when you switch yours.
Right.
So when the switch happens, I never know what the hell's going on.
Yeah, you just start getting used to it with one time zone or whatever, and they change it, and you have to start learning it again and getting used to it again.
It's so beautiful staying on one time. It really is.
Yeah. All right, well, Nathan, I reckon if we're going to wrap it up now, because where have you got to be, Rich? You got an hour to be somewhere, have you?
Yeah, I got to leave actually in about 20 minutes.
Cool.
It's about a 30, 40-minute drive.
Let's wrap it up. And
cool. Well, I'll say first and foremost then, a massive thank you to you, Rich. Absolute pleasure having you on. It really has been a delight. So thank you to you for being on Flat Earth United. I think I titled this.
Yeah. Well, thanks to both of you. You're the one that's actually hosting it. I don't have my computer set up, or if I do, I don't remember. I did this one time a year ago, and or so, and I just haven't done it since. So I got to go back and get used to doing it again. I just do live chat, so I really appreciate you hosting this, Nathan.
Yeah,
it's
me
an
too.
Absolute pleasure. Absolute pleasure. And thank you to you too, Anthony. It's been a delight listening to you and seeing your evidence as always.
See you later, guys.
See you later. Take care, guys.
And also, I'll say a massive, huge, enormous thank you to all of the live audience for tuning in and hopefully sharing this discussion. If you hated it, you know exactly what to do, but if you liked it, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!